الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/gdgmina.
Hello, everyone. My name is Ahmed, and today I'm going to talk about Kotlin Multiplatform and scaling it on more platforms. This is considered kind of a part 2 talk to a talk I've given a bit earlier on GDG MENA, where we've built a prayer times app for Kotlin Multiplatform, a prayer times calculator for Android and iOS. And this will kind of be a part 2 where we continue this and scale using Kotlin Multiplatform to other platforms. To start off with, we'll go through a little bit of a review for those who haven't seen the first talk, or as a refresher for those who have. So we have our repository, and in it there are 3 primary folders. There's an Android folder for the Android app, an Apple folder right now for the iOS app, and a shared folder for shared business logic between Android and iOS. As far as the code is concerned, from the shared code that's there, one of the main things is the Salah calculator. Salah is another word for prayer times. It's the Arabic word for prayer times. And really, I've highlighted the important portions of this. It's the fact that we have a suspending function, so an asynchronous function, which will get the prayer times for a particular name. It's talking to this location fetcher, which will go and call APIs, Google APIs, to fetch the information it needs, like the latitude, the longitude, and another API to fetch the time zone information. And based on this, it will plug it into a library and get the prayer times for the particular location. In addition to this, if you notice also, there was a platform date formatter here. And this is one of the ways that we vary code in Kotlin Multiplatform, was using expect actual, where we have an expected class and we have an implementation class. And as was mentioned in the first talk, this is just one of the 2 ways where we can differ business logic depending on the platform. And it's usually the other way of using interfaces is the more recommended approach, because it allows the native developers to actually implement the interface in the language that they are more comfortable. However, in this case, we are using expect actual for various reasons. So this will become an important detail throughout this talk. So then the actual implementation of this platform date formatter on Android, for example, just uses the JVM simple date format class, and it just calls dateformatter.format to translate an instant into a string. This instant is very similar to the instant available in Java 8 and above, which Android will desugar, but it's the one coming from Kotlin X datetime library, which is a KMP library by the JetBrains team for dealing with date times. The other portion of the code that's interesting is on Android, for example, the way that we get these prayer times is we have a repository class with a single function called search. And inside of this function, when we search it, we launch a coroutine to calculate the prayer times, and we update a flow with the newest value of the prayer times that we have received. On the iOS side, it's very similar, where again, we have a search function. It calls the same suspending function, and the suspending function, Kotlin Multiplatform, will translate into a Lambda callback. And then we update this published variable with the updated prayer times object that we receive from the calculation, which will allow SwiftUI, in this case, to re-render that portion of the screen. So that's kind of a very, very quick summary of where we are today. The first talk will go into goes into this in more detail if you'd like to look it up. But for now, let's start from there and see what we can do. So I have the project here, and actually I'll just run the demo app just so you can see what it looks like. I can enter the name of a city here. So for example, I can enter Dubai, and I will get the timings for Dubai, or I can enter something like Cairo and get the timings for Cairo. I can enter US zip code, for example, and I can get the times for that as well. Similarly on iOS, if I run it here on the simulator, again, I can kind of do this. I can calculate the timings for whichever locations. So that's where we are now. Let's start by actually expanding this out. And maybe the first good platform to do we'll work with is the desktop. And so we're going to make a new module for desktop, similar to our Android module, which has the Android code. I have a bash script that I wrote to make this a little bit easy. All this is doing is very similar to if I had used the new module wizard, part of the IDE. But I do this because it generates exactly what I want and not much more. So I'll make this a KMP library, and I will give it JVM main, and I will call the package app.soleh, and I'll proceed. And all this does, if you look, like it just modifies the settings.gradle.kt to add this new thing, and it adds a new folder with an empty build.gradle file. So this desktop thing here has an empty directory with this empty file. So I'm actually going to fill in this file with a predefined thing. Now you might be wondering, like, okay, I want to do this. Where do I get this from? In this case, this is coming from the JetBrains Compose repository, where basically this is a copy of their build script there. And all it does is defines a single target, JVM, with some dependencies for Compose Desktop and coroutines. Now, before this, I think one thing we will want to do, the main thing, okay, wait, let me see. So let's actually go ahead and create a main class here. And again, I have a pre-populated one, which is just creating a window object, giving it the title prayer times for desktop with a width and height of 300 dip. And for now, I'm just going to do just a text with hello GGG MENA. And I can run it, desktop run. And here we go, hello GGG MENA. So we have it, so that's good. So what we really want to do is we want the same UI as on Android. And because of the fact that desktop Compose can actually share the UI logic that Android has, we should be able to do that. But first, before we do that, we need to be able to access the shared repository from the desktop file, from the desktop module. So we'll go into the dependencies here, and we will add implementation project of our shared module. Now, when we try to sync this, it will not work, hopefully, although it might, who knows. But really, it won't work if we try to build it. And the reason for this is because if we were to open the shared modules build, we'll see that that these are the only platforms we're supporting here. We're supporting Android, iOS, and the iOS simulator, ARM64. If we try to run this today, right now, like if I did the Gradle run command right now, it would actually fail because it will say, I'm looking for a JVM artifact, and I can only find, the closest thing I can find is an Android artifact, which isn't quite the same. So let's fix this. And we'll fix it in a not so ideal way right now, but we'll go back and improve it. I promise. So for people who are sensitive to this stuff, I apologize in advance that I'm gonna do some copy pasta here. But I promise I'll make it better in a bit. So essentially, the JVM dependencies are exactly the same as the Android dependencies. We can use OKHTTP in the same way. So for KTOR, which we're using for web, we can use the same KTOR client of using OKHTTP, and similarly for the tests. So we can sync this. And again, if we try to run, we'll have another issue. which comes back to what we mentioned before of this platform date formatter. So this needs to be implemented for every platform. And as we can see, there's a red squiggly line here saying, hey, you don't have one for JVM. And so we'll create one for the JVM. And really all we need to do is copy the one that we have under Android, because it's essentially the same. This is a JVM class and not an Android class. So I can actually just replace this like this, and we have our implementation of the platform date formatter. So great. So now in theory, what we could do is we can open up main activity from Android. You can literally just copy paste this code in theory, and it should work. And so actually before that, we don't have access to the classes that if we were to copy paste, because some of these classes like search bar and prayer times views, these are custom composables that are here. So what we want to do here is we'll copy these two folders, and we will paste them in desktop. And again, I apologize. We'll fix this soon, inshallah. So we'll open each one and make sure that everything compiles fine. So we have different package. So I just fixed that. And same thing here. I fixed that. And same thing here. I also noticed that the enter key is experimental here. So we add that. And the other thing it's complaining about is preview. And if we open the imports, we can tell why, because the import for preview was Android X Compose UI tooling preview, whereas it replaced it with Android X Compose desktop UI tooling preview. So this preview annotation is different for desktop than it is for Android. But we can see that besides that, the code is pretty much identical. We've literally copy pasted, for better or worse, the code from Android into desktop. So, okay, let's try to actually run it now. We want to replace, so this window is similar to set content in Android. It opens a composable scope for us, or actually, I guess the application does. Application opens a composable scope for us. We'll basically copy this here. We need to create our own prayer times repository as well. And just all we need to do is fix these imports. And in theory, that should be it. We should be able to just do this and it should work. So let's see. So it looks very similar to the Android UI because it is. And hey, it's working. So we can, so we can calculate times for different cities. And that's great. Okay, so this is pretty powerful. We've literally copy pasted the Android UI code and the business logic, and we're sharing it on desktop. Let's go and clean this up. So the first thing we noticed is the copy paste of all these classes, which really wasn't ideal. So let's actually fix that. So we're going to create a new module, and we're going to call it renderer. And we're going to make this a KMP library with a common main with the same package. And we're going to come here. And again, I have pre-filled the build script, which essentially is just saying we support 2 targets, JVM and Android. And for everything that's common, we'll support Jetpack Compose, so UI, runtime, foundation, material design, and we'll share the shared project. And so we can actually go into this render project now, and we can actually move these things that we had before. So from the things that we copied, the data and view fields packages, we can move them here. And let's open those and make sure everything is good. So you see this one's fine. This one's also fine. This one gives us an error because of preview, because now we've moved this into common main. And this package, preview, is a desktop package. So the way to actually fix this, if we wanted to fix it, was we would move the JVM annotation for the preview, the JVM version, into JVM main and leave the Android one in Android main. But for the time being, I'm just going to remove the preview because we don't really need it for purposes of this demo. I can go back to desktop, and in addition to implementing using the shared project, I can also share the renderer. And I'll also open the Android one as well and do the same thing. and we'll sync. And then we'll go now to back to our main class, and we see that everything theoretically is being read. So let's try to run it now again and see if it works. Okay, so it's working. And let's make sure we didn't break Android. So let's check the main activity here. And I think some of the packages on the main activity should have broken. Oh, because I forgot to remove these guys from here. We don't need the duplicates anymore. And so we need to fix these package names. But after that, everything should be okay, and we should be able to run Android as well. And it's working. So, okay, so great. So now we've removed a lot of the code reduction, but we still have the block of set content, which is still being duplicated. So let's actually also stop duplicating that as well. So I'm going to copy this here, and I'm going to go into my render module, and I'm going to create another Kotlin class. I'm going to call it prayer times wrapper. We'll make this a composable function, and we will paste what we copied from there. I'll fix the imports. And we'll take the prayer times repository as a parameter as well. And so now we can go into main activity and replace this with prayer times wrapper, prayer times repository. We can get rid of this, all of this stuff, and clear the imports. And we can do the same thing here. And let's rerun this on Android. And hopefully it's working. It's working great. And then let's rerun on desktop as well. And it's working. So, okay, that's great. Also, just as an aside, in real life, I probably would not have included material theme. I would have made that not part of the wrapper. I would have let each kind of OS determine the theme, because I probably wouldn't want them to look identical. But in this case, I kind of want them to, so I'm leaving it here. But just as an aside. So now we've cleaned this up pretty much, and it's working pretty well. The one remaining thing that we haven't done is clean up the build script changes that we did, the copy paste that we did there. So let's go ahead and change that. And really, what we can tell here is that the JVM and the Android stuff is identical. And since Android can read JVM, things built on JVM, as we know, then we can actually remove all of the Android specific stuff. So I can go ahead and remove the Android plugin, and I can remove this Android block here. And in theory, and I can remove the Android folder from shared, which is here. And so in theory, it should still work on Android as well, because it should be able to read the JVM one, which again, it can. So, so now I think we are in a good state to make sure we didn't break desktop. So it's working, so great. Okay, so let's move on. We'll check this in here, just so that we keep our app now works on desktop using JVM. So yes, in case I didn't explicitly mention this before, this is using the what we just did is using JVM classes. So you can run this on Windows, you can run this on Linux, anywhere where you have a Java runtime. So let's support another platform now. And in this case, let's support web next. So I'm going to go ahead and create a new module. And I'm going to call it Web Compose. And there's also going to be a KMP library with a JavaScript main, no package name. And we're going to come here and I'm going to pre-populate the build script, which again, I'm going to comment out using our shared implementation project right now. And one other thing I need to do, I need to do some small setup things just for web, specifically for it. So I need a resources folder, and I need to create an index.html file here that is pre-populated with this thing. Just tells it the script to read is web compose, which is what will be created as a result of what we're going to do right now. I'll create a main class here. And again, I'll pre-populate this. And for now, I'm going to do a text with hello GGG MENA. And of course, if we look, we already see some different things. Render composable is similar to our set content. It opens a composable scope. But we notice now that the nodes that we're using are different. So whereas before we didn't have div, we had columns, we had rows. Here we have different set of web elements that kind of map to their corresponding web counterparts. So let's actually try to run this. So we can do a JS browser run, and hopefully, if things are good, we will get hello GGG MENA, which we did, which is great. Okay, so let's figure out how to. So what do we need to do? What we really want to do is we want to include our shared logic. But if we uncomment out this line and try to use it, it's not going to work. And the reason it's not going to work is similar to what we saw in the previous when we tried to support desktop, is because our shared module only supports JVM, iOS, and iOS simulator. And so what we want to do is kind of support JavaScript in our shared module. And so we tell it we want JavaScript, CommonJS, and browser. And we also need the JavaScript dependencies. So we will do this to get the JavaScript dependencies. And one interesting thing here is this dependency on an npm module, JS time zone. This is needed by the datetime library to adopt time zones. And we'll actually need to do one more trick to adopt time zones as per the documentation of the datetime library in order to be able to access time zones that are not GMT, which we need for a prayer times calculator to work. So I'll create this JS Joda time zone module class here, and we'll pre-populate it. Again, this comes from the Kotlin X datetime library. Their README file asks you to do this if you're using it in a web project. And then there's one more step that we need to do. Similar to last time, we have the case of our platform date formatter that, again, will need an implementation for JavaScript. So I'll go ahead and create an implementation for JavaScript. And we will say instance.toJavaScript date. Again, this is a JavaScript method. And we'll say to locale timestring as the way that we're actually formatting the times there. Okay, so great. So now we should be able to, I guess we've already synced this, but let's make sure. And we should be able to access this, and we should actually be able to start implementing on web now. So let's actually do that now. So what do we know? We know that from the slides, we remember we have this object called a calculator. And what we know is we need to use this calculator to calculate the time. So really what I want to do here is calculate that prayer times for some name like this. But we see that from the squiggly line and from this icon here, we remember that this is a suspending function. And I can't call a suspending function except from the proper coroutine context, right? So we can do that by having a launched effect. And this will allow us to call this method. So let's actually create a variable for now. And I'm going to call it placename. And we'll hard code it to Dubai for now. And this parameter to launch defect, this is a key parameter that tells launch defect to only rerun when place name changes. Since for now, this is a constant value, this will never change. And so this will never rerun. It will only run once. But even with this, nothing interesting will happen. And the reason for this is because what will happen with compose is when it starts this composable scope, it'll see a div, it'll draw it, it'll see this text, it'll draw it, and then it'll say, oh, you're asking me to launch a coroutines to call this method. It'll call it, but that's it. So what we really need is a way to tell compose that, hey, something's changed, please redraw. And so what we really need is a state of the current prayer times. So we're going to do prayer times is a remember mutable state of, we'll start off as null. And the type of this will be an optional Salah times variable. And this is what the API, the calculate method returns. It's a simple data class with the name of the city and the 5 prayer times there as strings. So we need to render this now. So let's actually render it if it's there. And so we can say current times equals prayer times dot value. And we say if current times is not equal to null, we'll render this div, and we will have a text of current times dot name, and then 1 for each of the 5 prayers. So I'll go ahead and change this real quick. And finally, we actually need to set this prayer times value so that this thing invalidates, because the first time it runs, it'll check this value is null, it won't draw anything. What we really need is to set the value here once we've done the calculation. So we can say prayer times dot value equals the calculate method. And we'll actually run this, and I will run with the continuous flag so that when we're changing things, we don't need to continually ask it to rebuild every time. It'll automatically pick up any changes when we save, and it'll allow us to see our changes just slightly faster. And so we see here that, hey, we have the prayer times for Dubai, but this is not very not very readable. So let's make it better. So we'll go back to the code, and what we need to do is let's clean up this a bit. We know that a div will give you, we'll wrap this in a div, and what we need is something like spans, right? And we need a span with a label that's bold and maybe some padding and the place name. And actually, just like this, we'll actually see once it's built, so it's building under the hood. But now once it's built, we have hello GGG MENA. We notice the hello is kind of bold. And what I want to do is I actually want to wrap this in a div as well. And then, basically I want to do this for my actual prayer time. So I want to do something like this. Sorry, this should be current times. And we will see once it's built and it reloads that, hey, we have the name of the prayer in bold, and then we have the time, and it's on its own line. So, okay, so in theory, I can just copy paste this 4 more times, but that wouldn't be kind of nice because every time we change it, we'd need to clean this up. So what we can do instead is we'll create a new composable. We'll call it prayer times row, and we'll make this a composable function. We'll take in parameters of the label, which is a string, and the value, which is also a string. And then we'll paste our div and span there and tweak it accordingly, fix the imports. Oops. And we'll change this to be label, and we'll change this to be value. And now we can actually go and replace this whole thing with prayer times row, like this. And in theory, things are good. Once this, where's the terminal? Yeah, it's built, so we can see it's still working. We can adopt the same change for these lines as well. And we can do this. the names of the prayer times. And in theory, once it builds, great. Now we have a nice UI for it. And if we wanted to tweak something like the font size, we can do it in one place and it'll apply for everything. Let me actually increase the font size so that's clear, but that's kind of what it is. Okay, so let's actually, but a prayer times calculator is not very useful if it only gives you the prayer times for Dubai, right? So what we want to do here is we want actually text input. So we'll do a text input. We'll say this is input type of text. And we will give it attributes. And we'll say on input. So what do we want to do actually here? So this will show us an input field, but as we know, compose is only going to go through this once unless we invalidate. And so what we need is a state of the current input text. And so we'll create another state called input text, which is, remember, mutable state of that starts as a string. And every time the text changes, we're going to say input text dot value equals it dot value. And the reason we need this is because then we can add a button here. And the content of the button is maybe like a text that says calculate timings. And on the button itself, we'll have an on-click listener where we can use now input text value to trigger the search here. So what this means is today, the search happens due to place name changing, and place name right now is constant. So we need to change this to also be a mutable state of an empty string in this case. And then really what we want to do is when you click the button, we want to set the value of place name to be the value of the input text that the person has typed in. And that would cause this launched effect to invalidate. And with it, we can then redo our calculations as well, which should cause everything else to invalidate. And so if we look here, assuming it's done building, we can hopefully type in something like Cairo and click calculate timings, and we get the timing for Cairo. We can change it to Dubai, get the timings for Dubai, Los Angeles, and we get the times for Los Angeles, and so on and so forth. So it's working. So, okay, so great. I mean, if we wanted to, of course, we could expand this. We can kind of be smarter about this and kind of do something like place name, location equals place name dot value, and just say, do something like if location is empty, null, else, actually calculate the timings. We could do something like that to kind of be a little bit more nice and not hit the API in that case. But again, here we have it. We had to write our own custom UI for this, but we can see we've been able to reuse all the prayer times calculation logic, including the ability to go to a to hit an API endpoint, fetch data, and so on and so forth here, which is very powerful. So, okay, great. Let's move on to the next one. And I will again kind of save our state here. App now works on the web. And okay, let's actually, let's shift gears. And we now support desktop and we now support Android. Let's support macOS natively. And so I can open my iOS project here, and I'll create a new target, and I will click on macOS, and I'll click on app here. And so I will call this app OSX, and I'll create this app here. I need to do a small tweak here, which is I need to give the ability for outgoing connections to the network, because otherwise Mac apps are sandboxed by default. And so I won't be able to hit the network without checking this box first, very similar to the Android permission. Okay, but there are a few things I need to be able to do before I can make this work. First and foremost, as we know, the shared module today only supports, JavaScript, iOS, and JVM. We need to make this support Apple platforms as well, like macOS. So I'm going to add a platform here called a macOS ARM64. If this were an Intel one, I would have done macOS x64. But since this machine is ARM64, so we're doing this one. Now, technically, what I need to do is kind of similar to what we did in the JVM case, where I need to kind of copy paste this because I can reuse the same dependency on macOS that I can use on iOS in this case, because this works on all Darwin platforms. So it'll work on Mac, it'll work on Watch, it'll work everywhere. But that won't be very nice, right? And so what we want to do is we want to utilize what KMP calls HMPP, which is the ability to kind of have hierarchies. And what we really want to do is say, hey, we have this concept of an Apple main, and everything then, iOS, macOS, everything can depend on Apple main, and we can customize specific things for iOS if we need to. We can customize specific things for macOS if we need to, right? So let's do that. So say Apple main, and in this case, we have to do by creating. All of these are by getting, and because of the fact that we've mentioned this name here, iOS, it knows there's an iOS name, main. It knows there's an iOS simulator ARM64 main, macOS ARM64 main. But in the Apple case, it doesn't know that yet. So we're going to say creating. So we're going to create a source set. We're going to say this source set depends on common main, because everything should depend on common main. And we're going to move the dependencies from iOS main here. And now what this allows us to do is we can go to iOS main and say, hey, iOS main depends on Apple main. And we can also do the same thing here. We don't need to depend on iOS main for the simulator. We can depend on Apple main instead. We can do the same thing for the test if we wanted to. So we can say Apple test by creating. And then iOS test can depend on Apple test. And actually, we probably want to say that Apple test depends on common test. And similarly, then here, we can depend on Apple test. And okay, this is great, but all we've done now is we've said that, hey, iOS main will read. So iOS main, if we can see, it's being highlighted here because IntelliJ detects that we have an iOS main source set and it's reading it here. All this is saying is if there's code in an Apple main source set, we'll read it for iOS, which we don't have today. And so what we really want to do is we want to rename this to Apple main. And so I'm going to use the terminal for this, and I'm going to move shared source iOS main to shared source Apple main. I'm going to come here, and because we didn't sync yet, we don't see it as highlighted. So we'll sync. And now you can see it detects it as a source set. And the other thing we need to do is we need to explicitly support ARM64 and tell it that macOS ARM64 should also depend on Apple main. Now, this has saved us from needing to do what we did before, which is re-implement the platform date formatter. Since we've implemented it once for Apple main, iOS will get it, the iOS simulator will get it, and macOS will get it. And so we're actually good here from the shared side. Now this code is, as far as KMP side is concerned, this shared library is shareable with macOS. Now we need to do one more piece of setup before we can actually go and make this work, which is we need to go to the pod file, and we need to support we need to actually tell the pod file that for the OSX target to read the shared our shared Kotlin Multiplatform module. So we do this and we do a pod install, and we should be good to go now in Xcode. So what do we really want to do here? We want to do something very similar to what we did when we shared between Android and desktop, which is we really want to share this data repository and the views, the Kotlin Multiplatform, the Swift UI views, be it the prayer times or the prayer times wrappers, between iOS and macOS in this case. So we'll create a new a group called shared, and we will move these two folders there. And we'll also move the content view there as well. And what we really want to do is we want to select all of these and say, hey, there's this dialog here called target membership. We want to say that this is not only available for iOS, it's also available for macOS. And now that we've done that, we don't need this copy of the content view anymore because we actually want to use our shared one. And we can just go here and we can do something similar to what we do in iOS, which is provided with the content, the object, environment object of the prayer times repository. And we need to import our shared module here. And in theory, so I'm building it now, but actually I'm building the iOS one. I will need to switch the target. So here are the targets. This is iOS, and I will need to build the macOS one now. So I will build this, and it's building because I built the iOS one the first time accidentally. And it's building and it's building. And now if I run it, I get the app running natively on macOS. And again, like I said before, this is really powerful. Like we're reusing business logic for a native macOS app, for a native desktop app, for a native for a JVM app. And again, it's all the same code. The same shared code. The UI is different, yes, but the UI here, even the UI we can share between iOS, for example, and macOS. So that's great. Let's actually do another one. So we'll go ahead and check this code in. And app works on macOS. And let's support watchOS now. And so this will be very similar to the exercise we did last time. So we'll start with the shared module this time. And we'll say that in addition to working on iOS and the simulator and macOS, this now works also on watchOS and the watchOS ARM64 simulator. And we'll go here again, and we need to tell it that watchOS main depends on Apple main. And we need to tell it that watchOS simulator ARM64 main also depends on Apple main. And from the shared code perspective, we're done. We don't need to do anything else. And as another argument for not using expect actual, if this weren't an expect class, we probably wouldn't even need to do this, right? Because the interface could be in common main, and then we don't need to actually implement directly in once for Apple main, once for JS main, once for JVM main, but we actually might provide it as an argument from the actual native code. But anyhow, we're done with the shared side now. Let's go back to Xcode and create a new target like last time. But instead of a Mac one, we'll do a watchOS one, and it'll be a watchOS app. We'll call it Salah Times, and we'll say finish. It's asking me if I want to activate the scheme. I'll say okay. And again, what we want to do is same as last time. We need to go to the Apple folder and update the pod file accordingly. So watch pod file. Did I call it? The name has to match, so it does. So pod install. And again, kind of similar to before, I need everything in the shared module to be visible for the watch app. And I don't need the pre-built one. And I want to import shared here and do the same thing I did last time, which is share the same code, the same rendering code with iOS and macOS. And so let's try to build this now. And it's building and it's building. Okay, and now we can run it. it's running. Let's see. Okay, and obviously this is not the nicest interface for a watch app, but the point is it does work. So let's say New York. Let's say done. And it's giving me the prayer times for New York. And so again, we're sharing the same business logic in KMP between all of these platforms. And in this case, we're also sharing the UI logic between macOS, iOS, and watchOS. Okay, so cool. Let's do another one. So again, let's save our progress here. So app now works on watchOS. And okay, now let's support one of the experimental things that Compose is working on, the JetBrains team is working on, is having Compose work on iOS. And you know, Compose is split into, there's Compose UI and there's Compose. And Compose itself is kind of the underlying manipulation of trees and nodes in order to, render a composable hierarchy, a set of composables, and manage them properly and know when something changes, what to re-render and what to re-render efficiently. And then it leaves that compose layer has no Android specific logic, and therefore that layer is being shared. It's just pure Kotlin, and that's what allows it to be shared on all these different platforms. And then on top of it, Compose UI, the one built by Google, creates a node type for rendering things on Android. And then JetBrains came along and made one for rendering things on the JVM and for rendering things on the web. And now it's also worked on one for rendering things on iOS. So what we want to do here is a little bit different than last time. Last time we were changing the shared module, and the shared module, remember, just has our business logic, right? It has our API calls, it has our prayer times calculator, and so on. But this is not what we want to change this time. What we really want to change this time is the renderer module, the one that we shared with desktop and JVM. And we want to share this exact same code and exact same logic with iOS. And again, this is experimental, so there will be some kind of little bits of things here and there we have to do in order to make this work. So all I've done here is I've added support for iOS and the simulator, and I've given it the ability to create a CocoaPod. And then, as I said, it's experimental, so there are certain issues that happen if you don't set these compilation flags today. Since we've included CocoaPods, we need to include the CocoaPods plugin. So I need to do this, and yes, so this actually will give me an error saying Compose targets UI kit are experimental and may have bugs. And so in order to actually make this work, you actually need to explicitly opt in and tell them, I know this is experimental, let me use it. And so we set this UI kit enabled to be true. And again, to work around another bug, we need to set cache time to none. Again, these are things that hopefully will be fixed in future versions. Okay. Now, actually, if we were to actually try to do anything with this right now, it would not work because of another bug, which so happens to be that any composable that you have cannot be public if you're going to use it in iOS. And what this means is this composable is public now by default. If any of these composables is public, it will not work. And so we have to make every single composable either private or internal. So I'll go ahead and make this internal. And I will make the wrapper internal. And I will make the search bar internal. And of course, we kind of broke, even though we're not supporting iOS yet, we're working on it, on supporting iOS with Compose. We know that by making this internal, we've broken Android and we've broken desktop. And so we'll need to fix that. And so we'll fix that by creating an object here called prayer times wrapper provider. And we'll have a function called wrapper, which takes in the prayer times repository, and it will output a composable function. and we'll set this equal to prayer times wrapper of prayer times repository. So this is just a very roundabout way to expose this, even though it's internal, to Android and to desktop. So you can open our main activity now. We'll see that it's complaining, but we can actually just say provider.wrapper here. And actually, it's giving me a warning because this is a Lambda. So this is a function. This is returning a function, but it's not calling it. So I need to call this function. And I can either call this function by doing this, but I prefer the other syntax of just calling invoke here. But they're both identical in this case. And so Android should work. We can test it now. And in the meanwhile, so yeah, Android's still working. Assuming they have network access, etc., etc. Yes. And let's go ahead and fix it on desktop as well. And again, we can do desktop run. Oops, what did I break? Oh, import, bad import. Let's see, desktop run. And it's working also. I'm very creative with the city names, as you can see. But okay, so great. We need to do one more thing for iOS, which is when we notice that that we use this code on the desktop, we had this application function to basically start a composition for us. And on Android, we also had set content to start a composition context for us as well. And we need something similar on iOS, but we won't be able to do this in iOS as well, directly as well, right? So we need to do this in the rendering code as well. So what we really want is we want iOS specific code. So we need an iOS main folder here. So I'll just make a directory under the render source, and where there is a common main, I'll make an iOS main. And I will give it a Kotlin subdirectory. Let me make sure because I always mess this up. So yes, so I'll give it a, so we have an iOS main folder here where you can put iOS specific logic that will not be visible to Android, but will be visible to iOS. And before that, let me make one more change, because if you remember, there's iOS and there's iOS simulator ARM64. And if I do nothing, the simulator ARM64 will not have access to any code I add here. And so I will add support here by saying iOS main by getting, and iOS simulator ARM64 main by getting, and make this depends on iOS main. Here, we'll resync this. And we'll create a class here, and we'll call it root view composable. And this is basically another object with just a prayer times repository. So this has its own application call. And in this case, if we look at the definition, we can see it's returning, it's a bit small, but you can see it's returning a UI view controller. So this is actually a composable function. This is starting the composition that will ultimately return a UI view controller for iOS. And so if iOS calls this, it'll get a UI view controller that it can render. So okay, so great. We're done on this side here of the shared logic. Let's go and actually implement this on Xcode. So I'm going to create another target, and it's going to be an iOS application. And I'll call it iOS Compose. And I need to do one thing here, which is I need to, by default, since I just created this using SwiftUI by default, I need to actually change this parameter to a no, so that I can actually make it use UIKit instead. And then, as the same as last time, we need to go into the Apple folder. We need to update the pod file to tell it to use the renderer. This time we're using the renderer pod We could also use the shared one if we want to, but since we will not actually access any of the shared things directly from iOS, we'll only use the renderer pod in this case. So I'll say pod install. And we'll go back and look at what we have. We don't need this content view anymore because this is for Swift UI. And what's generated here is Swift UI. So what I don't actually need it, and what I do need is a main that supports iOS app delegate. So let's change this target to iOS compose, and let's build. And it's still building because yes, from last time this didn't exist. We've added it, so hopefully now it'll be able to see it. It's building. And of course, part of what the build step entails here is calling Gradle to make sure that the framework is up to date. And that's kind of what takes some time. And that's why, for example, this is not seen now, but is usually seen once the rendering, once the build is complete. So you can see build successful. And so let's run it. And we can see it kind of worked. It's there, but I can't actually use it because it's under the safe area, what they call the safe area, under the dynamic island in this case. And so I can't actually interact with it or do anything. So to fix that, I have to fix that from the compose side, right? And what I really want to do is I want to support taking in an optional modifier parameter here. And so I'll say modifier is a modifier that I'm going to default to modifier. And I will set it on the column here. And I will update the wrapper to also be able to take a modifier as a parameter, defaulting to a default one, and passes it in here. And similarly here, since I'm actually calling the internal function directly, I can just do a modifier dot padding, and I want a padding on the top of 48 dip. And the imports need to happen here. So let's see. So that's one, and that's the second one. And so it should be good now. And so if we go back to Xcode and we run it, it's building. Building, building, building. And there we go. You notice it looks very, very, very similar, if not identical to the Android version, including the purple from the material design and so on. You can put in the city name and it's working. So it's working here again as well, right? And so this is really kind of compelling, right? We've shared the same exact UI code and business logic between iOS, desktop, JVM, and Android. And we've shared the business logic across even more platforms. And so this is very powerful and really neat. So let's do one last demo. So I'm gonna go ahead and save our progress here. Works on iOS with Compose. And I'm a bit of a command line person myself, as you might have seen from all these this usage of the command line. And so I really want a command line app. And the first time I did this, I actually built the command line app. I figured, what I can do? I can open Xcode, and I can do something similar to what we've done before, where I say file new target, and say Mac OS, and say command line tool, and build one using Swift. I will have the same access to the shared module as before after updating pod file and doing pod install. And then I will be able to write a command line app in Swift. But I thought about it and I was like, well, why not write it in Kotlin? And turns out we actually can. So let's go back to our shared module and let's go to our Gradle script here. And under macOS ARM64, we're going to add a binaries, and we're going to add an executable, and we're going to say entry point equals main. And then we're going to go under the shared Apple main module, and in this Kotlin folder, we're going to create a new class called main. And I'll make this a function main with arguments of an array of strings. Let me sync it first. And I can just go ahead and write an app here. You notice it detected that this is runnable. It's giving me the green run button here. So what do we want to do? Let's write a command line app for this. So the place will use the first parameter of the arguments. And if one doesn't exist, we'll default to Dubai. And then we will we'll have our calculator, same as we've done before. And we will say prayer times equals. In this case, we'll do run blocking, which isn't really the best thing to do, but in this case, it's okay. So we will ask it to block the thread and kind of calculate the times and give us the times. And then we'll say if the times are not null, we will print line prayer times dot name, and we'll kind of do this for every prayer time. So we do this, and that's it. And then I'm going to build it. It's going to take a bit, but macOS ARM64 binaries, we will build it. While it builds, so this is just Kotlin, right? And so in the same way I can actually make this work on macOS, I can actually make this run on Linux as well. And that's kind of part of what the point of doing it this way is. Whereas if I had written it in Swift, it'll run on Mac, but it won't actually run, for example, on Linux as is. Although yes, you can run Swift on Linux, but it kind of wouldn't make sense, right? So okay, still building. And I will show you, I guess, so all of this code and everything that we've kind of demoed is already there on GitHub. The link will be shared. But usually what happens here is that if we want this to actually work for Linux, we would need to actually also do something and say Linux x64 and do something very similar to this. Now, because we're using some libraries that actually need to link against libraries, so for example, Ktor on Linux can't use, if we look at our shared main, we see that Ktor, we're always giving a Ktor client. For JavaScript, we're giving it the JavaScript client. For JVM, we're giving it OKHTTP. For Apple clients, we're giving Darwin. For Linux, we need to give it curl, for example. And the curl client needs to link against libcurl, for example, right? And so let's see. Okay, so it's done. Actually, what it'll do is it'll generate a KXE file. And so you can see there's one here. There's a release executable shared.kxe and debug.kxe. If we do file on this file, you see it's a 64-bit executable ARM64. And if we run it, it's using the default of Dubai. I can actually I can just give it a city, and it's working. And it's working as well. So if I wanted to support Linux, what I would need to do, so first off, it doesn't make sense to keep this main file under Apple main. So the first thing I would do is I would create a native main and move this under it. So again, we can kind of use this same HMPP concept, and I can go here and I can say native main by creating. We can say that native main depends on common main, and we can change Apple main to depend on native main. And we will not copy these dependencies because we're going to use native for Linux as well if we wanted to support Linux here. And then we would create a native main folder here. So let's actually do that and see. So shared source, there will be a native main, and there will be a native main Kotlin. And so if we sync here, you can see it kind of highlighted this. It understands the source set. We can move our main.kt file here, and it's still okay. So we should still be able to run this on Mac OS. And now if we wanted to support Linux, we can actually have our Linux target depend on this one. So I'm not on Linux here, so I can't easily run this. But if I wanted to support Linux, we'd do something like Linux x64. And again, the same thing, binaries executable, entry point equals main. And I would go down to these dependencies and I would say Linux x64 main by getting, it depends on native main. And I would need to also add the dependency, but on the curl version, not on the Darwin one. So I'll change this from Darwin to curl. And then in theory, the one more thing I would need to do would be to implement this platform date formatter. And so then I can either create a new folder for Linux x64 main and do the platform date formatter there. Or, I mean, if I'm supporting Linux and I'm supporting Mac OS, why not support Windows as well? And I can also do that similarly here by, instead of Linux x64, by doing Ming W x64. Again, I can kind of do binaries executable, entry point equals main, and I can make, I can do something similar here where Ming W x64 main, also depends on native main. And I can have these same dependencies as in Linux because curl is shareable. libcurl is there on Windows and is there on Linux. Of course, then in this case, the next thing I'd say is like, why am I duplicating all this? And why would I need to implement the platform date formatter once for Linux and once for Windows? So I would do something similar to this, and I can say non-Apple main by creating. And this depends on native main. And we share these dependencies here. And then our Linux one would depend on non-Apple main. And same thing for our Windows one would depend on non-Apple main. And then I can go into non-Apple main. It will automatically read main.kt from native main because again, non-Apple main depends on native main. And we'd be able to go and create, non-Apple main and Kotlin. And, we'd be able to, let's say, sync here. And I should have actually created the package as well, so I'll do that. And once it syncs and detects this as a source folder, I can create the platform date formatter there as well, and support and have support for Linux or Windows. So yeah, so you can see it's kind of selected there, and I could do the same thing here. So I can create a platform date formatter if I wanted to, and kind of implement. Let's see, let's copy. It's not going to work, of course, if I copy this one, but we can copy it and tweak it. So we can do something like, we can do whatever we wanted to do here. So we can say like local date equals instant to local date time in the current time zone. And maybe I can do something like return local date dot hour plus local date dot minute with, and I want to pad it to string pad start length 2 with 0, meaning that if the minute is 1, it makes it 0, 1, or if it's 9, it makes it 0, 9. If it's above that, it leaves it as it is. And so we've implemented the platform date formatter that would be used for Windows and Linux if we wanted to here. And that's about it. In reality, to run this on Linux and Windows, it's a bit more complicated, like I said, because of the fact that this curl dependency will need to link against curl at build time. And while LLVM, I could cross-compile theoretically from my Mac to Linux or to Windows, it's a bit tricky to do so. And so usually what we do, or what the Kotlin team recommends, and what you'll see in a lot of the repositories, is that instead of actually doing these explicitly like this, macOS, Linux, and Windows, they'll actually have some sort of selection logic, which will choose the right one based on the current OS and do that. And I'll show you this, since either way I don't have Windows or Linux here, but I'll show you this kind of in the repository. Let me increase the font size. Again, this is prayer times-kmp under Ahmed RE. The link should be shared, but it's actually doing the exact same thing. So if I open up shared and build.gradle here, you'll see that there's some check for the host OS. And it says, okay, when it's Mac, use macOS ARM64. When it's Linux, use Linux. And when it's Windows, use Windows. This label that I'm giving it here, non-native, non-Apple native, allows me to, instead of saying Linux x64 and Ming WX64 for these, I can just do something like non-Apple native main to refer to both Mac and non-Mac. And I say, hey, if I'm not on an Apple platform, whether it's Windows or Linux, doesn't matter, depend on native main and depend on the curl dependency. You'll find also in this repository, you'll find instructions on how to run it on Linux. I did not actually try running it on Windows, to be honest, because I don't have a Windows machine, but it does run on Linux, though it does need some setup, like you need libcurl installed and such, but it does work on Linux for sure. I guess, so we're done with that. Actually, so I think one more thing I want to kind of mention here before we come to wrap up is that the fact that we're now sharing this logic is super powerful in the sense that I can actually now go into common main here, being that this common logic is shared between all these different platforms. And I can say, you know what, hitting the endpoint makes the app slow. I have to spend 2 to 3 seconds to go and fetch this data from the API. And what I really want to do is cache it. And I can build a caching layer. I can build a caching layer and have that caching layer work throughout for Mac, for iOS, for the watch, and so on and so forth. And I can even go as far as building that caching layer to cache in an actual database, something like SQLite or something like that. And so I will actually update the repository at some point with an example where this caching is implemented. I have it working locally, but needs a bit of cleanup before I can merge that. But it's really powerful to just be able to make some code changes in common main and then have everything work on all these different platforms. So let me wrap up here. So why is this useful? So some cases why this is kind of useful, very multi-platform applications. So think about an application like 1Password, where it works on Windows, it works on Linux, it works on Mac OS, it has a command line app. This would be very useful. Now, for them, they're using Rust, which makes a lot of sense due to their needs for security and so on and so forth. But in theory, right, for another app, this could be a viable option. Command line applications, which are useful not only for, because they're cool, but also useful for testing, right? So I might be building an app that I'm sharing business logic between just iOS and Android, but it's nice to be able to say, hey, instead of building the iOS app and the Android app, I'll have a command line app that allows me to test different scenarios without actually testing the UI. Similarly, on the same line, it allows me to build test applications. Or for example, if I'm writing an Android app, maybe I want to test on the desktop instead of testing on Android because it's a bit easier. I don't have to deal with the emulator or a device or so on and so forth. Another thing is this iOS Compose is very intriguing. While I would not actually ship it to production because it's far too Androidy and it renders on iOS natively using Skia. It's really intriguing the fact that it works, and it's an interesting thing to keep an eye out on. Though I would probably expect a lot of applications and companies using KMP to manually implement UIs in iOS to get a more native experience. And another super cool thing, and there are some talks in DroidCon of New York from this year by Square about how Square is using something similar to this to update their mobile apps in production. So I write the business logic in Kotlin Multiplatform. I ship it with Android, I ship it with iOS, and I also ship it to JavaScript on the web. And what that allows to do is have the JavaScript be readable from the app, and the app can say, hey, if I'm using a version that's out of date, pull the newest version of the JavaScript code and run it through a JavaScript interpreter and run the logic that way instead of running it through the logic from iOS or the logic from Android. And so, as we all know, that when we update mobile apps, you release a new release today, you don't get a huge amount of adoption until sometime down the road. And this could be very powerful for things like that as well. That's all I have. So I guess thank you very much.